Hello everyone. Today I would like to show you how to validate the molecular docking and display data for 2D-QSAR model. This is the outline I will discuss today. First, we mentioned about software for performing QSAR 3D. Second is step by step for molecular docking and how to display data, and we can discuss the result. In here, the example show the 3D structure of promising compound and target protein. And this is the 2D structure so detail how the promising compound target with amino acids. And after that, you can show the table like that. For example, here the compound 25, this is their structure, the ID from PubChem, this is the IC50 from the observed, this is the actual data, and this is IC50 from the predicted by different models, and the docking score from the targeted protein and the binding site with key amino acids. Here I show you a lot of software, right? You need to download the whole software here to performing molecular docking. For example, here AutoDock did the link, and more of them is free, and you can download and you can install in your laptop or computers. It is the step, the outline how to dock. Step 1, you need to repair protein structure. Step 2 is repairing ligand structure, and step 3 molecular docking. Step 1 is how to repair protein structure, because after you download from the RCSB database, your protein have some kind of problem. For example, missing atom, missing residue, incorrect number hydrogen bond, or system is not charged, some kind of thing like that. So you need to use the MOE software to fix the protein structure before docking. Next one is you need to remove the ligands or water from the protein structure, and so you also need to add the hydrogen bond and command chart on the protein structure. After that, you need to calculate the coordinates x, y, z, and finally you need to import to PDBQT file for molecular docking. Second step is repair for ligand structure. You need to optimize your ligand structure using the Avogadro programs. And after that, you add some kind of polar hydrogen bond or gas tier chart to the ligand structure. Finally, you also need to import to the PDQT files for further steps. The next one is you only use the command to run the molecular docking, and it can show you results. Third one is I want to show you how to validate the docking process. Why we need to validate the docking process? Because the purpose of QSAR 3D is identify the new compound, right? But you need to compare with reference drugs. For example, here, this is the donepezil, this is the FDA approval for Alzheimer's disease treatment. So you need to use the compound to compare with your targeting ligands compounds into the same active site with targeted protein. So in here, after you run, you can need to choose the model with the RMSD less than 2 and dock skin core is high compared with another model, and it means that your compounds is similar with the reference drugs. So after that, you can show the results like that as I mentioned before, right? And you can publish your data. So this is my YouTube channel. I will upload a lot of videos related to QSAR, step by step how to perform mean QSAR model, and you can follow and you can study and you can make your own data and you can publish your results. So here I will show you detail how to perform mean molecular docking, right? In these papers, I focus in on the acetylcholine ester, the enzyme play important role in Alzheimer's disease with the ID from the RCSB 3LII. You can see here, this is the RCSB. You can search here the free database. You can see RCSB, and after that you only try the targeting protein. For example, here if I copy, you know, the name of the protein, right? You can see after you search here, they show you a lot of proteins related to the acetylcholine, right? But which one is the best one? So you need to choose the protein with the high resolution. You can see here, you need to sort from the resolution, right? The worst, the best. It means that they will show you the protein with high resolution. For example, here the resolution around 30 is very high one. But up to your purpose, you need to identify the promising target protein based on your study. But in here, I already know my protein is around 3LII because I know this is the recombinant protein acetylcholine etera with highest resolution. So in this video, I will download this protein. And you can see I saw in the folder, and I copied it. I go to my desktop, I paste it. Then I will go back to the slide here. You can see here, the first time you need to remove the ligand or water from the structure, right? So you need to open the software they call Discovery Studio. Here I go File, Open. So my folder is docked in here, right? And after that you go to Scripts, Visualization, Publication Quality, and we from View Hierarchy. And you can see here the compound including, you know, you can go here including ligands, water, and in here you need to remove the ligand. You can see the ligand and the water in the structure, right? So after that you need to save it. File, save it to here, but you need to choose the file PDB, right? So here I just that remove, right? But I think here just one. Save it. So you need to close it. So now here your protein. Let me go back again here. You need to finish here, right? The next one, you need to fix your protein. You need to go to the MOE protein, and you go to make it bigger. File, Open, Desktop, Docking, and this here the number one here because I remove ligand and protein, right? You open. You can make bigger and smaller by your mouse, or you can rotate like that by the ball here, and you can go to the protein and go to protein structures, and you can see here they show you a lot of mistakes, right? For example, incorrect number hydrogen bond, system not chalk, or everything here. So you only click the correct, wait a minute, and they can correct the mistakes from your structure protein. It takes time. So in here they already correct, so you need to save it. File, save, and go to the desktop, go to docking, and here I will set at 3LLL number 2. But in my case I want my file PDB, so I change my file PDB and I save it. Let me check again. Here also still MOE, not. So I will go back again. I to save it. New file, save it. Desktop, docking. Within here, BDB, PDB, yeah, protein data bank here. So PDB, okay, PDB, okay, and I save it. So now you check again. Yeah, this is your compound is now is PDB, right? So now you already uh, uh, finished two steps, right? The first time you need to fix a protein ligand, and the second one is you already remove ligand water in here. Next step, you need to add polar hydrogen and command, right? You need to go to the AutoDock tool. Wait a minute. Wait a minute. They will remind later, and you can see here. So you only need to drop your protein in here. So in here, I wrap my protein in this website, and it will show you the protein, right? And so now you need to go to edit. You need to delete water, right? Because we already did water, so no change. You need to add chalk, and because add the command chalk, as I mentioned before, right? Okay, and you need to add hydrogen and polar. So next one, you go to grid, you go to the macro protein, you choose, and you select your protein, select protein. Wait a minute, because protein too big, so take times. So after that, they said that chalk should be correct written output, and you just okay here. And after that, you save it in the same folder. My folder here, I put that. I only save. Okay. Okay. So in here, I compare with donepezil. Donepezil is the reference drugs for FDA approval, right? So in here, I need to go to the the PubChem. I download the donepezil, right? You click donepezil here, and you can click here, and you can download. You can download the structures. The 3D structure. You need to download 3D structure here. Download, and the file FDF here, right? So in here you can go to the Avogadro here, Avogadro here, and you can go. Let me copy my file to the login folder here, and you can grab to this software. You can see here, this is my structure of donepezil, right? And you can see here, the already 3D, right? But you need to optimize your ligand, right? By the fork fields and 500 step using the Avogadros. You can see here, you go to attention, you go molecular mechanics, and set the fork fields, and you choose the MMF94 and 500 step, and you click OK, right? And after that, you can go file, you save it, and because I want to save at the BDB file, right? So I go to the desktop, I go to docking, and here I call my donepezil, right? And my BDB file, I save it. So check again. Donepezil done, right? Donepezil. Let me change a little bit. Donepezil, like that. So I will did again with another compound, compound 25 here. So I also, because I know my compound have the ID like like that. Let me check again. you can go to PubChem here again, go PubChem here, you can go search here, and you can search the ID, right? You can search the ID 118727071. Okay, and click enter. The compounds, yeah, you target, right? So you dissimilar, go to the 3D conformer, download it, FDF, and open the Avogadro again. Open Avogadro again. Let me copy him to the my folder in the laptop, in the desktop, and I only grab my ligand in here. In here I will did again, right? Attention, go to the Fog Fields, and I click OK, and after that I save it. I set that compound 25 PDB. I set up in the desktop my file compound 25 PDB. Okay, so we don't need him, we need to close it. So the next step for the repairing ligand, right? You can see here, after that you need to add the polar hydrogen and gas chalk, and after that you need to import the PDB file, right? So in here I will open my AutoDock again, AutoDock here. So in this case I don't need him, I will delete him. Okay, I will dig with donepezil first and move here, and from here you need to go to ligands, input, choose the ligand, and select with dock and VDS the gas chalk and polar merged with 29 polar hydrogen, and click OK. And after that you go ligands, output, save BDP, desktop, go to the docking here, I set at donepezil, right, with the BD-PVT, you save it, right? So in here you delete again, and you did with similar compound, it is a cellular ligand, it's like one compound 25, right? You did again, ligand, input, choose compound 25, select, add the gas chalk and hydrogen bond. Okay, and ligand, output, save the top, docking, and compound 25, save. Okay, so I will close. No, I need to delete him, right? So because here after that, go back again, right? You already finished, right? Import the PDQT, right? So next one, you need to dock, right? You need to calculate the XYZ. So in here, you need to add the protein first. You can see here, I will make the folder here. The folder here is for donepezil, and the acetylcholine. My protein is acetylcholine. Acetylcholine. The second one is new compound 25. 25 and acetylcholine, right? Because we want to compare with the parent drugs, right? So in here, you let me wait a minute. I will go to my folder. I will take my file, sub research in silico QSAR study, docking, and command configs. Let me see, configs donepezil. You need to have two files here. I will upload on the comment box. Now you need to drop, right, the compound 25 here, compound 25 with let me see, compound 25 with PDB, PDVT. 25 here, and the acetylcholine BDQT in here to the program. So after that, you need to go to the grid, open macrophase, open let's see, grid macrophase, choose. And because here they don't know which one is a protein, which one is ligand, you need to choose the protein because macro protein, right? Macro protein is the acetylcholine. You select, and now we already everything, so you no need to want to reserve everything. You said no, right? Click OK. Click OK. So wait a minute, and after that you need to go to the grid box, as I mentioned before, right? In the PowerPoint PPT here, you need to let me see why so small. You need to choose the grid box with 40 plus 40 Armstrong and 2.375 Armstrong between the point, right? And in here you already select, right, the default one, right? The current total grids per map is 64,000. The number X dimension, Y dimension is 40, and the space Armstrong around 375. And now you need to take the result from the X, Y, S. So in here I go to my folder. Let me my folder, my document here. Let me see, I close it. Where is my folder? My folder here. My folder here. I make smaller. I need to make the config for the my protein here. My protein receptor is protein, right? 3 LIL. Let me see, LIL 2, and the ligand is donep, right? Let me see, similar with my protein donep. And the X here I need to input around 6A265. The Y is 777229A, and here is 11A9. And the X, Y, yes, here the energy drain is, we put the default around 4 and its source effectiveness around 8. So just save it. So now you can copy the config here to the compound 25, right? Donepezil. Let me see, donepezil acetylcholine. Let me see here. Go back again. You need to copy your compound donepezil here, BDP here, and the compound and the protein here to your file here. So in here you no need to put here code here, replay, right? Let me see again, check again. In this folder you need to have protein BDQT file. The second is donepezil BDQT file, and the configs. You can see here the configs here. Oh, let me see, I config wrong. Maybe I take here donepezil here, config, replay it. Yeah, this is my correct one. The ligand is donepezil. The receptor or protein is 3LLI2, and the center XYS, and the side XYS energy drain or assortiveness here. And then after that I click, I close it. But because as I mentioned before, right, we need to validate it with we need to validate your compound with reference drugs. So you need to use the same the binding site with the reference drugs. So in here you need to copy this config file and the compound 25 and the protein here in your compounds in your disk folder. So you only change the ligand here, the compound 25 compound 25, and you save it. So it's okay. Because the reference drugs have the active site at the XYZ in this um, in these values. So now you need to compare the promising compound with similar reference drugs. So you need to use the same config files. So after that, easy. As I mentioned in the PPT, right? You can use the code for docking here. You can see. I also mentioned in the PPT, right? You only copy, the folder here, the link of folder, and you go to the. Let me see. Go back again. Go to the code for docking here. And you paste it. CD your link of folder, and make sure that you need to download the AutoDock Vina, because after you download and you install, they will give you the link around the indexing program Crypt Research Institute Vina plus doc ESE, right? After that, you only change your ligand and your protein, here. For example, here, because my ligand is 3LL2, right? My protein is 3LL2, and the ligand is my donep, right? So in here, with the config files, log and output. After that, you Control A, Control C, and you go to search here. You go to the command prompt, and you can pay it. And they said that they will run the docking. But wait a minute, they said that they will align the bindings, and they did the performing research. They will show you the results. It takes time, because if your docking score is high, the time is longer rather than the docking with lower values. So just wait. Wait a minute. So during that time, I will show you the result. You can see here. After that, you can show the result like as I mentioned before, right? You need to choose the model with the IMSD less than 2 and the docking score is high. So let's wait. How is it going? Around 60%. Let me see. Let me see. Yes, this is the results from your docking score, right? You can see here they show you around 10 models, and in here they will show you a lot of model, right? But the first one is very high score, right? You can see around minus 4.4 7.4 with the MSD around 0, right? But this is very good ones. This is a good model, right? But you need to choose in here. You need to choose the IMSD less than 2 and the high docking score here, right? But the first model is a good one, right? The IMSD, the docking score is the highest, minus 74, and the distance from the RCSB 0. So it is the model 1 is the good one. Or you can choose another model, model 6 is good, right? Model 6E not good. Model 6E around 7.2 less than Model 2, but the IMSD is too high, so Model 1 is the best one. Similar with that, you can perform with the compounds 25. So I will show you again. You go to docking code for docking here. You want to change here is compound 25, compound 25, Control A, Control C, and go to the command here. You run again. After that, let me see here. Because I choose the wrong folder, you need to choose the folder again. Go back here, go to the link here, and you paste here. And after that, Control C, Control A, Control C, and go to command here, and you can paste. And after that, they can run, right? So after you run, and you have the similar result, and you need to now you have, right? You have structures, you have the ID, you have the predicted everything, you have docking score. As I mentioned before, you choose the model with the highest docking scores. And now how to show the binding site with amino acids, and how to show the results like 3D and 2D model like that, right? So in here, during waiting, the compound 25, I will show you did with donepezil, right? Donepezil, I need to close everything here. I need to close it. I don't need him anymore. And also here, I will, let me see. Wait a minute. You need to go to the discovery software. Wait a minute. It takes too long because it's heavy. After you open this software, you can go file, you go open, and you go to docking folder, right? As you can see here, you go to the, because I already did docking with donepezil and acetylcholine. You go here, you go to choose the old file, go to the protein, your protein. Because here you can only copy this protein, and you go to file again, open, choose the old file, choose the output, right? After that, you Control C and only paste. So in here, you need to go to scripts, visualization, choose the publication only. You can see your protein and ligand, right? And now you just define, this is your protein, define protein. And because I want to select the model 1 is the best one, I should define ligands, and I click ligand interaction. You can see here, this is the ligand interaction between the protein and target, right? So now how you can add the hydrogen, the amino acid? You go to label, go add, and here I will choose the amino acids, and the name here I will choose the letter ID in section code, and here I choose the Ario, and I choose around 16, and my color is the black one. After that, you can see, and this is my amino acids. So in here, I will add more information. I want to add the hydrogen bond in my 3D structures here. You can see. Wait a minute. Yeah, you can see here they have a hydrogen bond donor acceptor, or you can add the chalk or super SAS or hydrophobic hydrogen bond, up to your purpose. You can choose everything. And in here, I want to make the change the color of ligand, and because here I choose the blue one, and I click here, you can see, and you can right click, move, and rotate or you can rotate by right click here, and you can rotate the complex between structure and ligand to make sure that it can visualize easy, right? You can see here, and you can add more, so distance, so type of interaction in here, right? But in here it is 3D structures. After that, you can find, save it, and you can go to your orient folder, right? You go here, you can save by the figure image, and I can export it your figure image, right? So the another one is you can show the 2D diagram that I mentioned before, right? And here they will show you, this is your potential compounds binding with the amino acids with a lot of interaction, right? The green one here representative from conventional hydrogen bond. The another one for carbon hydrogen bond or alkyl or pi alkyl. And you can also save it, file, save, and in here already choose the image file, you can save it. And now you go to your folder, you go back to your folder. Let me see with my folder, docking with compound docking, and here I will turn off. So you go to the Nepal folder, and now you have your data, right? You can see here you have this is 3D structure with protein and amino acids, and this is a 2D structure between the donepezil and acetylcholine. In here, after you run the compound 25, right? You can see here the result from compound 25 and acetylcholine. You can see here they have the highest score, docking score around 7.2, minus 7.2, and the IMSD around 0 here. The good model, right? And you can choose the model 1 for present compare with the donepezil. So here I will did again to show you again how to perform the data. Go here again, you can close it. You can close it. You can save it first, and save it, because here you already upload the protein, right? You only copy, and now you only go file, open. Now I want to show result on the compound 25, right? I go to the compound 25 folder, and I choose the old file, and here I will choose the output, right? Similar, I click paste, and here I choose the visualization, publication only, and you can make it much smaller. And here, right, you need to identify protein first, and after that the model 1 is good one, I will define the ligand in model 1, and in here I click ligand interaction, and similar with that I right click label, add the amino acid on the ligand, and in here the current ligand here I want to change the color to the blue one, and here I want to add the hydrogen bond like that, and you can rotate to show the ligand and receptor like that. After that, you can show distance, show ties, and you can file, save, and here you choose the image file and output. Another one is you show the 2D structure, right? And here you can see they have a lot of interaction between the compound 25 and acetylcholine. The first one is the green one is conventional hydrogen bond, the play important roles in their interaction, right? Another one is carbon hydrogen bond, pi sulfur, pi star, pi T set, or pi alkyl. And you also save it. Finally, you can present your data like my paper here. The first one I show the 3D structure. The second one I show the 2D structure with detailed amino acid. And another one you show the docking score here and the binding site with key amino acids. I hope this video will help you how to align the docking cores and also how to validate the docking process. So more information you can go to my YouTube channel and you can study more. I hope this video will help you. Thank you so much for listening.